Welcome back to day 9. Today, we're not going to learn anything new. Today, we're just going to take a step back and we're going to reflect. Our goal for today is to be able to distinguish when to solve quadratics using factoring versus the completing the square method. All right, so today it's about reviewing and practicing and really understanding when to use each type of solving for quadratics. So, when should you use completing the square? Well, if your question says radical form, you should probably use completing the square. If your question tells you to round, you should probably use completing the square. Or if your question says completing the square, make sure that you use completing the square. Or if your problem just is unfactorable, then you have to use completing the square. So those are kind of just the key ideas of when to use completing the square, radical form or rounding. Okay, key ideas there. So when are you going to use factoring? If your question does not tell you to round, if it doesn't say radical, that means you're going to get perfect integer solutions, and it should work out to be able to factor. As a reminder, your solutions are called your roots or your zeros. Okay, so now we're going to take a look at a couple of examples and we're going to look to see how we're going to solve here. So let's take a look at number 1. It says solve for the value of x. Okay, now, does this tell you to radical form? Nope. Does it say to round? Nope. So this means we're going to use regular factoring. Okay, to solve this one. All right, so let's take a look. Let's go ahead and let's do this one. So let's take a look here. So for factoring, let's take a look. X to the third, 4x squared plus 3x equals 0. So we're going to solve this by factoring. Remember, what's the first type of factoring you always try? GCF. So is there a GCF here? Yes, there is. And that GCF is x. And then we're going to go ahead and do a big set of parentheses, and we're going to divide an x out, because we put it on the outside. So we're going to get x squared plus 4x plus 3. Now, can we factor the inside of the parentheses? We sure can. We're going to use our trinomial factoring there, and this x goes right to the outside. So x, two numbers that multiply to 3 add to 4, plus 3, x minus, plus 1. So they're both pluses. All right, now we're going to set up our t-table. Now remember, x here was to the third power, so that means there's going to be 3 answers. So we actually have our double t-tables, because everywhere there's an x goes into the table. So this is x equals 0, x plus 3 equals 0, so then x is equal to negative 3. And x plus 1 is equal to 0, so x equals negative 1. So our 3 answers are 0, negative 3, and negative 1. All right, let's take a look now at number 2. Solve for the value of x. Well, let's just actually start solving this one, because I really don't know what we have to do yet. So let's take a look. So here with fraction equal to fraction, we're going to cross multiply. So x times 2x plus 5 is equal to 7 times 1. So now we're going to distribute. 2x squared plus 5x is equal to 7. Okay, so now our x is to the second power. If x is to the second power, that means there's 2 answers. 2 answers, we set it equal to 0. So we're going to transpose the 7 to the other side. 2x squared plus 5x minus 7 is equal to 0. Now, this is a quadratic, so we have to make the decision. Are we going to solve using completing the square or factoring? Well, does this problem tell you to round? Nope. Does it tell you simplest radical form? Nope. That means it should be factorable. So let's take a look. Is there a GCF? Nope. We can't use stops. We can't use trinomial because this number is bigger than 1. So that means we're going to use the grouping method here. So let's go ahead and practice that. 2x squared blank blank minus 7 equals 0. Now we take the first number and the last number and we multiply them together. So we're going to get negative 14. So can you think of two numbers that multiply to negative 14 and add to 5? Well, I think that's going to be 2 and 7. So I'm going to go ahead and do a negative 2x and a plus 7x. Now we group together the first two and we do GCF. So the GCF here is 2x and then x minus 1. We go ahead and the GCF over for the second two terms is a 7, and then we get x minus 1. Okay, so now we have to finish our factor by grouping. So x minus 1, those are the same, so that's our first factor. And then our second factor, we put the outsides into a set of parentheses. And the whole thing is equal to 0. So now that we've factored it by grouping, now we can set up our t-tables and solve. So x minus 1 equals 0, so x equals 1. And here we get 2x plus 7 equals 0, so I subtract 7. 2x is equal to negative 7, and then we divide by 2. So x is equal to negative 7 all over 2. And now we've got, our final answer there, so you can see that. Okay, so both of our first two we solved by factoring because it didn't tell us to round and it didn't tell us to have a radical as an answer. So let's flip the page over and let's take a look at number 3. So number 3 says, solve for x. Leave in simplest radical form. So as soon as I see those words, simplest radical form, that means I'm going to have to use completing the square. Okay, and then if I take a look at number 4, solve for x, round to the nearest tenth. As soon as I see these words, round to the nearest tenth, that means it's not going to be factorable. I'm not going to get perfect integer solutions. So that means I'm going to have to use completing the square. Okay, so we're only going to do one of these for today, so let's go ahead. We're going to cross off number 4. We're just going to go ahead and complete the square for number 3 here. So just a little bit of a review here. So for completing the square, so here we're going to bring the 8 to the other side. So x squared minus 4x, in its place we're going to put a square, is equal to 8 plus a square. Now I'm going to take this middle number, I'm going to go off to the side. I'm going to do negative 4 divided by 2, which is negative 2. And then I'm going to take negative 2 and I'm going to square it, and that's going to give me 4. So I'm going to put a positive 4 in my square. So now that we've done that, now we're going to factor the left-hand side. So can we think of two numbers that multiply to 4 and add to negative 4? Well, sure, it's negative 2 and negative 2. And that's the same number we got over there, is equal to 12. So now instead of writing this twice, I'm going to write it once and I'm going to square it. Now we need to get rid of that squared. So to get rid of the squared, we're going to square root both sides. So now the squared and the square root are going to cancel. We get x minus 2. And remember, when you take the square root of something, you get the positive and negative of that solution. Okay, so now we need to bring that 2 to the other side because we need to solve for x. So we get x is equal to 2 plus or minus radical 12. Now, it did say simplest radical form. Can we simplify radical 12? Well, here's my little think bubble. Let's check it out. Radical 12, is there a perfect square that goes into it? Yes, there is. Radical 4, radical 3. So we take the square root of 4, we get 2 radical 3. So I can replace that with 2 radical 3. But remember, we've got two answers here. So x is equal to 2 plus 2 radical 3. And x is equal to 2 minus radical 3. Those are your two solutions. All right, many times we also see these types of questions in multiple choice form. So if we take a look at number 5, it says, what is the solution of the equation? Okay, so for this one, we take a look, 2x squared plus x minus 3. Now I see that I have a 2 in the front. So if there's a 2 in the front, I can't use completing the square. Completing the square has to have a 1 in front. So here we're going to solve this one by grouping. Okay, and then if we take a look at number 6, and when you solve that by grouping, you do get B. Okay, what I like to do is I like to put our focus on number 6. If x minus 3 squared equals 5, then x is equal to, now does everybody see how all of these have radicals? So we're going to take this and we're going to finish this by using the completing the square method. Now, if we look carefully, did they already do a lot of the work for us? So if we take a look at what this looks like, look up above, doesn't that kind of look like that step right there? So they already did half the question for us, we just have to finish it. So let's go ahead and finish this using completing the square. So we're going to take the square root of both sides. So that's going to get rid of the squared, so we get x minus 3 is equal to positive or negative radical 5. And then we add 3 over. So x is equal to 3 plus or minus radical 5. And we can see that that is choice A. Okay, what I'd like you to do now is flip to the next page. Now that we've reviewed when to complete the square versus when to factor, I'd like you to practice on these next 2 questions. Have a great night, everyone.